Unit 3B was when we started talking about higher order polynomials and how to solve those for their x-intercepts, how to solve those equations. With these, this is when we started talking about polynomials that we couldn't necessarily factor, and we had to do the rational root theorem too. And so that's what I'll talk you through here in these next examples. With these, one of the first things we want to look at, like we've been doing on the other ones, is what our domain would be. Again, this is a polynomial function, so I am technically allowed to plug in any number in the world until I finally find the few answers that would actually work. So the domain of this is negative infinity to infinity. Our answers can be absolutely anything. Then when you're looking at the problems, what we did was we always tried to factor first. If you were going to be able to factor, it was going to be factor by grouping. So you would want to see if you could draw that line to the middle and factor it. In this case, it looks like it might work. So I can pull a 2x out of the first 2, and this gives me x squared minus 3. I can pull a 2x squared. And then it just gives me x minus 3. I'll pull a 5 out of the back, and it gives me x minus 3. So this problem actually is just factorable, which means I don't have to do what we specifically talked about in Unit 3. Or 3B, I'll get to that in a second. For this one, how you would finish it, you would set each factor equal to 0 and solves. This gives you negative 5 over 2, and then you would square root everything. And then remember, you do have to rationalize. So multiplying by root 2 over root 2. This is going to have an I in it, and then it's going to be root 10 over 2. Those are 2 of my 3 answers. The third answer comes from this binomial right here, and it gives me x equals 3. So just because it was Unit 3 doesn't mean we did rational root. Sometimes it worked out like this problem here. However, that wasn't always the case, and so we'll look at one that's a little bit different. Again, for my domain, it is still going to be negative infinity to infinity, because you can plug in anything you want to this until you magically find the right answer. I can't factor this. There's not even 4 terms, and it's not quadratic form, so I can't do that. So this is where we apply our rational root theorem, and we list out our possible zeros. Your possible zeros are when you take the factors of your last term, so the 4, and you write that on top, so 1, 4, and 2. And factors of your first term go on bottom, so again, 1, 4, and 2. The order doesn't matter. I'm not sure why I didn't write it in order. I apologize. And if you know what this fraction means, you're welcome to leave it like that, but if not, I would split it apart. And what you have to do is take every numerator and put it over each denominator. So if I put all of them over 1, it'd be plus or minus 1, plus or minus 2, plus or minus 4. If I put them all over the 2, I'm going to have plus or minus a half. If I do 2 over 2, that's just 1, and I already have that. If I do 4 over 2, that's just 2, and I already have it, so I don't need to write that. And then I'm going to put them all over the 4. So 1 over 4. 4 over 4 is just 1, and so I don't need to write anything else because I already have it. 2 over 4 is a half, and I already have it. So these are my total possible zeros. There's 10 total options there. And we have to do synthetic division to find which ones of these actually go in. And actually, when we did it in the chapter, we gave you 2 options. You either synthetically divide in until you get a remainder of 0, or you plug these numbers in until you get 0, and then you synthetically divide in what worked. Okay, so what I'm going to do, I need to fill in my coefficients. This one is extremely important. You notice you have 0x squared here, so it needs to be 4074. And then we just have to kind of guess. So if I put a 1 in the box and I do the actual synthetic division each time, the 4 comes straight down. 4 times 1 gives me 4. 0 plus 4 is 4. 4 times 1 again is still 4. That's going to give me 11. Okay, that does not give me 0. So I need to try a new number. Again, this is where guess and check. If you prefer to just type in your calculator and then synthetically divide once, that's fine. But I'm going to do the synthetic division. Okay, so 4 drops down, but now it's 4 times negative 1, which is negative 4, which drops down and gives me a negative 4. -1 times -4 is +4. This is still 11. This is -11. Well, that's not going to be 0. So again, I have to try again. That negative got me closer, so I'm going to try a negative here again. Let's see, 4 times -2 is -8. That comes down, gives you -8. This gives me 16, and that already pretty much seems like it's going to get way too big. We can try, I'll try a fraction. Maybe a half will work. The 4 comes down, 4 times a half is 2. 0 plus 2 is 2. Half of 2 is 1. 1 plus 7 gives me 8. Half of 8 is 4. That got very close. My signs are just wrong. So what I'm going to do is make this a negative half and see if that changes it. Negative half of 4 is -2. 0 minus 2 is -2. Negative a half times -2 is going to be 1, which gives me 8. And now that gives me a -4, and I actually get a remainder of 0. So negative a half goes in. That is my first solution, so I need to remember that that's there. The other thing we talked about when we did division with a fraction is we have to divide all these numbers by 2, because that's what the denominator was. So when I go to write this in my binomial, the binomial will be 2x plus 1, because we basically unsolved x equals -1/2 to get that. The trinomial would be what I get from doing this division. So 2x squared minus x plus 4. So I already know one of my solutions, it's -1/2. I need to find the rest of them. This means you might be able to factor, you might be able to quadratic formula. It's just all going to depend each time. I would always try to factor. 2 times 4 is 8, adding to -1. It's not going to work, so I do have to quadratic formula this one. Filling it in, just like before. -4 times 2 times 8. Sorry, I did the multiplication in my head. 4 times 2 times 4. All over 2 times 2. That's going to give me 1 minus 16 times 2. Just don't want to get this wrong on accident. 1 minus 31. This gives me -31 all over 4. I can pull that negative out as an I. 31 is prime, so it's not going to simplify any further. So that's 2 of my answers. And my other one answer is this -1/2. So this one would only have one real solution, the -1/2. The other two would be imaginary from getting that quadratic formula there. So this is going to be another one where we have to rational root it. Feel free, like always, to try it if you need to, or if you're ready to, and then listen to the video when you are ready. We're going to have to list out our roots. If we tried to factor this, it wouldn't work. Factors of the last, it's just 1. Factors of the first, it's 3, so the only factors are 1 and 3. Which that means for me, my factors are either plus or minus 1 or plus or minus 1/3. And this is where the guess and check comes into. I'm not missing a term this time, so I can just fill all of that out. And if we just start, I'm going to start with a -1 because all of these are positive, and so somewhere I probably want to be able to subtract. The 3 drops down. 3 times -1 is -3. 7 minus 3 gives me 4. 4 times -1 is -4. 5 minus 4 is 1. 1 times -1 is -1, and it looks like I got the right answer. Again, one of my factors will come from this, and it says if you had unsolved it, so it's x plus 1. And then since this isn't a fraction, I can just fill in 3x squared plus 4x plus 1. I would always, like I've said, try to factor that. So multiply to 3 and add to 4 is 3 and 1, so it looks like this will factor. 3x squared plus 3x plus x plus 1. Oopsies. Pull 1 out of the second part. And this will factor You'll have the x plus 1 from the original. You then have 3x plus 1, and then another factor of x plus 1 from factoring your trinomial. When you go to solve, you will get -1 2 times, so it's -1 molt 2. If you think about those graphs, that means it would turn around at that point. And then the 3x plus 1 gives us -1/3. Those are my 3 answers for this.